Link to objects. The LINQ, or Language Integrated Query project, is a code name for a set of extensions to the .NET framework that encompass language integrated query, set, and transform operations. As a matter of fact, LINQ was received so well by the programming community that they never changed the name from its code name to some formalized technology name. So LINQ has stuck, and it is still in use today. There are LINQ providers for virtually anything that provides data, such as SQL Server databases, ADO.NET datasets, XML documents, .NET collections, or virtually any .NET array type, all using a common syntax allowing for ease of implementation across the technologies. So once you learn LINQ, you're able to apply over 99% of it across all these different providers. LINQ heavily leverages functional programming to define search criteria and return values for queries. As a matter of fact, the functional programming techniques we learned before, such as the anonymous methods and the predicate syntax, will be used heavily by LINQ, especially in our examples. Now, LINQ was considered an add-on technology to the .NET 2.0 framework libraries, but it's an integral part of .NET 4. So when .NET 2 was released, there was not a whole framework release until 4. 3 and 3.5 are simply stack additions to the .NET 2 framework, but .NET 4 encompasses all the technologies natively. I've included a web address here at the bottom that you can follow that will give you a much more in-depth look at LINQ than we will be covering in this class. LINQ query operations consist of 3 distinct actions. First, you obtain the data source that you wish to query. Then you create the query against the logical contents of the data source, and then execute the query. By default, LINQ queries do not iterate through the source data until the result records are actually requested. This is known as deferred execution. This is very useful since you are able to define a query before ever having to expend the resources to execute it. So you can define all of your queries ahead of time and then only execute a handful. LINQ is especially useful when considering that it can be applied to collection types that you are already familiar with. So rather than delve into LINQ to SQL Server or LINQ to XML at this point, we're just going to look at simple LINQ to objects, which means we're going to look at our list class, our array class, all of the types that we've been using up until this point, and show you how you can get more sophisticated searching, sorting, and querying than you've used up until this point. If you're familiar with SQL, LINQ will also be very familiar. There are basic constructs that are used by a LINQ query. There are the from and group, where, order by, and select parts. From identifies your data source. Group allows you to group the result data into distinct lists. This will be useful if you want to break things down more granularly, like you have sales reports where you want to group by the quarter, where each quarter lists out the months. Where allows you to define your search criteria. This is basically going to eliminate values that are not wanted. Order by allows you to sort the resulting list in the order that you would like to display them possibly. Select is the final piece where that identifies what you wish to select out of the resulting data. Select is more powerful than just simply saying, get me what I asked for. You can actually use transformations to select brand new objects out of thin air that will be smaller subsets of the original source data. Again, if you're familiar with SQL, all of these names will look very familiar. The biggest difference is where select shows up. Select typically is at the last or the tail end of the statement rather than the front end as you would find in standard SQL. Each part can be implemented with a specific syntax added to C# that is very, very familiar to SQL again, or by using these functional programming extensions that we've been talking about. Some of these parts are optional, mostly depending on which style of programming you choose. Now, for instance, if you're not interested in the order that the values come back, you can skip the order by clause completely. Or if you have no criteria, but you just simply want to sort a list, you can simply use the order by. If you compare the IntelliSense list for a generic list object in C#2 and 4, you will notice many new methods like select and where. These are new extension methods defined in the system.link namespace. So if you create a string called s and then type s dot, IntelliSense will provide a list of functions like first of tsource. However, if you remove the using system.link statement from the top of your code file, those functions will no longer be available. Again, it's because they were added as extension methods. They are not physically part of the type that they're referring to. So using functional programming techniques discussed earlier, you can execute these methods on a list object or array or anything that exposes an enumerable type. So we can filter the results. Constructing queries in this fashion is known as the method syntax. The result of a LinQ query is typically an IEnumerable object that can be later iterated through. Remember, these queries are not actually executed until the resulting IEnumerable object is iterated through. In this example, we are assuming a person class with the following members. We have an ID property, a first name property, a last name property, and a date of birth property. We also have a getAge function that returns the age of the person based on today's date and their date of birth. Assume we also have a generic list of person types called people. The first example is going to show us how we can use the where clause to filter the original list of people. Notice the return type is of type IEnumerable of person. A lot of people here will use var instead of IEnumerable person. It'll still come out as a list of person objects, but var is by far easier to type. When you have a concrete type coming out, in other words, a well-defined and well-known type like person in this case, I recommend using the IEnumerable of type person syntax. That way it's clear to the user or anyone else looking at your code what it is you're trying to accomplish. So the return type is going to be IEnumerable of type person. We call the query Q1. The first thing we do after the assignment operator is to say people. This is our data source. After people, we say .where. Where requires we provide it a function that evaluates true or false, also known as a predicate delegate. So in this particular case, we're saying where p being an arbitrary name we pulled out of thin air to represent every object that we're iterating through. So it's going to represent a single person in the list of people. We're saying where p such that p.getAge is greater than or equal to 40. That will return true or false based on whether or not each given person is older than 40 or equal to 40 as well. Therefore, when we execute Q1, it should return a list of all of the people who match that criteria. The second query is very similar to the first one, but we add the order by statement as well. And notice how they're chained together. We again have the IEnumerable of type person, and we call this one Q2. We set it equal to people. Then we say where, or .where, p such that p.dateofbirth.month is less than 4. So we're looking for people born January, February, and March. Then we issue the order by command by chaining that to the result of the where command. So we filter the values for the people born in the first quarter first, then we sort the list based on their last name. And notice that order by just asks which property that it needs to be sorted on. Since last name has a default converter, this is a default comparison method, there is no need to provide anything else other than saying p.lastname. So it'll use reflection to do all of the comparisons in the list of people that come back from the where command and order it by their last name. Some people ask whether or not you can interchange order by and where, and yes, you can. You can swap where and order by, and in that case, it'll order the list of people first, and then provide the where clause, which will filter that sorted list. Which one comes first depends on which one is going to perform faster. Most of the time, order by comes after where because where will filter the list and give order by less to do. Finally, we have an example where we're going to project a new value using the anonymous types we discussed earlier. So we have a return value of type var. The reason we have to do it this way is because we don't know the name of the data type that's being generated because we are projecting a brand new data type in line. So the return type is going to be var. We'll call it q3 equals people. And again, we have a where clause. This time we're checking for last names that have length, and then the first character of the last name must be less than or equal to m. So the reason we check the length first is to make sure we don't have an index out of range exception when we look for the first character out of the name. Then we order it by last name as we did in the previous example. Then we explicitly issue the select command, which is going to allow us to project a new type. And you can see we're saying select p such that there is a new object, and again, using the anonymous data type syntax, we construct a new object that has two properties, ID and last name. And notice here, we're taking the ID from the person, which was most likely a long, and then we're creating a string from it using the Social Security syntax or layout. So that actually makes it a string. So we're projecting a new type where the ID is a string, and then we're just passing last name through. So we have two properties of type string in this new data type. Not all of the four original properties, so we skipped first name and date of birth, and we actually transformed ID. This is a very common technique using LinQ. It's very similar to using SQL syntax where instead of doing a select star for your query, you select specific data columns. So if we were to execute the query Q3, every value that is returned from there, so if we were to say for each var v in Q3, v would have two properties, ID and last name. The previous example shows how you can use method syntax to query objects using LinQ. This, however, is sometimes very difficult to write and to read. There is, however, another variety of querying LinQ, and that's using something similar to SQL. Virtually every query can be written in either syntax, but most people tend to prefer the query expression syntax due to its readability. The following keywords are used to build a query. We have the from and end keywords, where, group, by, order by, and select. Very similar to the method names, except all of these, as you can see, are lowercase, and you will not access them using the dot operators. Again, let's make the assumption we have a person class with the same properties, ID, first name, last name, date of birth, and a method called getAge. Again, assume we have a list of person object called people. We are going to emulate the same query where we want people that are older than 40. And this time we're doing at least 40, so we're not using the greater than or equals. So it is slightly different from the first one. but it really shows you how you can write the query in a very similar fashion. So just like before, we have to identify our data source first. So we're going to say the IEnumerable of type person Q1 is equal to from person in people. So the people will identify the source data, and the person is very similar to the temporary p variable you saw in the previous examples. So every person that we're testing and querying for will be represented by this person field. So we're saying where person.getAge is greater than 40, order by person.lastname, select person. Now, as I said, most people will look at this query, especially if they have a database background, and be able to read it in a much easier fashion than the method syntax where we had to chain all of these together using dot operators and functional syntax. Now, if we were to compile this and look at it in IL code, you would see that they actually both generate method syntax. However, again, this is much easier on the eyes when you're working with especially a very complicated query. Now, the bottom query kind of emulates the last query we had in the functional or the method syntax, where we this time have a var for the return type, and we'll call it Q2. And again, we have from person and people. We have the same filter where we're looking for people with last names that start with A through M. And then we order by the last name. So we select the data source, we filter the data source using where, and then we order the sort the results using order by. Then we're going to project a new return type by using select new, and again we're going to use the anonymous type syntax to create an object with two properties, ID and last name. Again, this is probably much easier on the eyes, and it becomes much easier to manipulate and to extend this query to do even more sophisticated querying. We can also group our results. We notice we were able to filter them and to order them, but we can group the results into sublists. So the result of a LINQ query can be grouped into a list of lists where the outer list matches the criteria by which the results were grouped. The inner lists are the data grouped by that criteria. The outer list result values are themselves an enumerable collection and contained a value called key. That is actually a defined property of the values in the outer list, which corresponds to the value that was grouped by. An example of this would be to query a list of K through 12 students, grouping them into their corresponding grades. So let's assume we have that student class with the following properties: ID, last name, first name, and grade, which will represent kindergarten, first grade, all the way through 12th grade. And assume a list of student object called students. Now, we can take a new query, and we'll call it students by grade, and we'll say it's equal to from student in students. So at every step of the query, we have a student object, and it will be called student with the lowercase s, as you can see. Then we're going to order that list by last name and first name ascending. After that, we want to take the list of students and subgroup them by their grade. So we'll say group student by student.grade. It's usually always going to be a property of the object that you're grouping on. And then we're going to group it into a group called grade group. This is a temporary object that we can use from within this query. Once the query has been written, we pretty much lose the context of grade group. It just makes it easier to access things like the key of the group that we created. So as you can see in the next statement, we say order by grade group.key. So we have two order by statements. The first order by statement involves sorting the actual students. The order by after the group statement is going to order the groups. So first we order the students by their last name, then first name. Then we group each of the students into their appropriate grade, sorting by their grade number. And then we select the grade group. So what happens is we end up having a list of lists where the outer list is going to be the contents of the grade group, and the inner list is going to be our sublist of students, or IEnumerable of type student. So we can loop through the outer grade group by saying for each var grade in students by grade. Okay, so the outer query, which is the students by grade, gives us the grouping list first. So we can, at every step, output the grade. Because the grade itself, as we define here, var grade in students by grade, is going to be a group object. And the group object will always have a key. Since we grouped by the student's grade, it will contain things like K, 1, 2, 3, etc. So if actually it'll be 0 through 12. So if the grade key is equal to 0, we are assuming kindergarten, and we make sure with the ternary operator, if that's the case, we return a K. Otherwise, we simply return the key, which then will be either 1 through 12 or K if the value is 0. Then we can do a sublist, because grade is also an IEnumerable of type student. So we can say for each student, student in grade, and then each object at this iteration will contain a student object in their appropriate group. This is a very powerful syntax that allows us to categorize things, such as maybe we want sales figures by quarter. So we can have a full year of sales objects in memory, and then we can select all of them and then group them by their quarter. So we would group them instead of by a key. We would have a more sophisticated group statement where we would pick them by quarter. Another trick in Linq is to create temporary variables within the query itself. Using the let keyword, what we can do is define a temporary variable that points to some object within the query, so we don't have to write that subquery over and over again. We can just access that individual value anytime we need to touch it. So as I just implied, the let command creates subqueries. Okay, so we don't want to use the let command to define constants or things that don't change within the query. So say, for instance, we wanted to define a list of objects that we were going to query against, such as, let's look at our student example, and we wanted to get maybe high school students, and we know they will contain the values 9, 10, 11, 12. We probably wouldn't use the let command to define that sublist from within the query. Instead, it would be best to define them outside of the query and then reference them from within the query. It just makes it a lot easier, because then you only execute or define that collection of subgrade types once, rather than in the subquery where you might have it execute many times. So let's take a look at the first code example where we create this date type, and then we're going to get the members from this date type using reflection. So what we've created here is a data type. It's actually the type keyword, a variable called date type, and we say it's equal to type of date time. Then using the getMembers reflection method on that date type, we want to see all of the members from within that data type. So we just want to see what's in the datetime class. And then we say where member as property info is not null, and member as property info.name.length is less than or equal to 5. What we've done here is, since getMembers returns a member info object, which is the base class for property info, is we're looking to see, first of all, if we try to cast it using the as keyword and it comes out null, that means it's not a property info. So member as property info returns null if in fact the member that we're looking at is not a property info. So this will filter out all of the other things like methods, events, and fields that we're not interested in. So if we do have a property info, then we want to make sure that the name is less than or equal to 5. From there, we say select member as property info. Again, we've had to cast it using a direct cast as command 3 times now. We did it twice in the where clause and once in the select. Then we can loop through the property infos and print out the property names, which you can see on the right. We had date, day, hour, kind, month, now, ticks, today, and year. Well, in the second example, what I did after declaring date type again, we have query 2, and then we say from member in date type.get member, so nothing's different yet. Then we say let prop equal to member as property info. So that is where we do the cast from the object called member, and we try to cast it as a property info. Then, instead of having to repeatedly do that cast over and over again, we can use prop as a substitute. So then we can say where prop is not equal to null and prop.name.length is less than or equal to 5. Select prop. Notice again, when we did the select prop, we also didn't have to cast it one last time. So then we can iterate through the objects in the exact same way we did before. So this allows us to create a temporary variable that we can use to eliminate having to do the same thing over and over and over again within our query. Some other functions that you'll see when you include the system.link namespace are the following. Min and max allows you to get the minimum or maximum of a list using a selector function. Average of f, sum of f, gets the average or sum of a list using a selector function. Take n allows us to get the first n elements from a list, so it's kind of like the top function in SQL. Any determines whether the given predicate matches any item in the list. This is going to return true or false. So we want to say, do any of the objects match this criteria? All gets the list of all items that match the predicate criteria in the list. Again, it's very similar to any, but instead of returning true or false to indicate if that condition is met, it actually returns the objects of the list where the condition is met. Then we have count, where it says counts the number of elements that match the predicate criteria in the list. And remember, predicates, where you can see the parentheses p, predicate functions require us to have a function typically written in the functional programming syntax such that the function returns a true or a false. So why do we use functional programming techniques? Well, LinQ is the obvious reason. LinQ allows us to do very complicated queries without having to write our own syntax by looping through objects and testing for things on the fly. But it also enhances our code to reduce things like side effects, because methods implemented in a pure fashion using functional programming techniques don't address any values outside the function other than what was passed to it. In addition, these methods should not change the passed-in arguments. Therefore, every time you call that particular function over time, passing in the same arguments, you will always get the same result. So with functional programming, we really don't want to have the ability to change the values being passed in. We want to treat them as if they are static members and they or read-only members that can't be touched once they've been created. Now with transformation problems, the code tends to be shorter and fewer lines of code generally translates into fewer possibilities for errors. So very similar to the anonymous classes, which we'll discuss here in a second, the transformation problems where we want to take code in one form or data in one form and convert it to data in another form, the functional programming techniques allow us to do that in a very simple manner, and simple is always better. And the anonymous classes allow for specialized type objects created on the fly, which assist us in these transformation problems. So we don't have to use overweight objects, and the resulting objects are read-only. Therefore, they are only meant to be looped through, they're short-lived, and as soon as the query is done being looped through, it is now a candidate for garbage collection. Linq, which uses functional programming, provides a powerful syntax to query lists, arrays, data sets, etc. And unless your query requires an immediate evaluation, LinQ queries are evaluated only when iterated through. So unlike when we have to do our custom looping and then we step through each object testing for certain criteria, with LinQ we can write the query and it doesn't actually consume any CPU time until you iterate through the values to pull out the actual results.